the angle between the two vectors 1, 2, and 6, -8. Give your answer to the nearest degree. So the formula we use here is cos theta equals, I'm just going to name the vectors A and B. So it's going to be A dot B, or the dot product of A and B, over the length of A times the length of B. Now what I do is I often find all three parts separately and then plug them in. So A dot B is the scalar product. So that's going to be 1 times 6 plus 2 times -8, which is 6 minus 16, or -10. The bottom, to find the length of A, that is, we take this vector here, we square both parts, add them up, and square root. So it's the square root of 1 squared plus 2 squared, which equals the square root of 5. And the last one, to find the length of vector B, we take the square root of 6 squared plus -8 squared, which is the square root. 36 plus 64 is 100, so that equals 10. So you can then take those three values and plug them into the formula. So it's going to be cos theta equals the dot product, which we found to be -10, divided by A times B. So that's going to be root 5 times 10, so 10 root 5. Since they're asking for the angle to the nearest degree, we don't need to worry about rationalizing the denominator here. We can just plug into our calculator. So you could simplify it for sure. If you want to put less things in, so it'd be -1 over root 5. So on your calculator, you're going to go inverse cos 1 divided by root 5. And we don't want to put the -1 in because I'm looking for the reference angle. So theta R is 63.43, and this should be approximately because it's not, I'm rounding it. But the 63.43 is in quadrant 1. Cos is not positive in quadrant 1. It's going to be negative in quadrant 2 or 4. This one's going to be in quadrant 2. So your theta is 180 minus 63.43, which works out to 117 degrees. And again, it should be approximately. Well, because it's got to be negative. It's not going to be in quadrant 4 because that would be the outer angle. We want the angle between them. So what these vectors are going to somewhat look like would be something like that, right? I haven't drawn that well though, but the angle, because you don't want this part, you want the one between them. Well, quadrant 4 is going to be, would be over like 300 degrees or just under 300 degrees, so that would have to be obtuse. So it's got to be quadrant 2 to be between 0 and 180. Yeah, I haven't drawn them. For 1 second. Find the angle between the following vectors A and B, giving your answer to the nearest degree. So same idea here. We use the formula. Cos theta equals A dot B, or the dot product of A and B, over the length of A times the length of B. Okay, so A dot B is going to be -4 times 1 plus -2 times -7. -4 times 1 is -4, -2 times -7 is 14, so that's going to be +10. And it's coincidence that this works out to 10 as well. And then the length of A is going to be the square root of -4 squared plus -2 squared. And you guys can just correct me if I plug the wrong number in here somewhere. So it's going to be 16 plus 4, so root 20. And then B is going to be the square root of 1 squared plus negative 7 squared, which is the square root of 50. So we're going to now plug these values in. So we will have cos theta equals 10 over, and I mean you can combine these any way you want, but on the bottom we want to take root 20 times root 50, which would give us root 1000. You can simplify that if you want, or just plug it into your calculator like that. And since it's positive, we should get an acute angle. Like it should be between 0 and 90 degrees because that's quadrant 1 where cos is positive. Now again, that doesn't mean that our vector angle is going to be located in quadrant 1. It's just for the purposes of determining the size of the angle. So if we go on our calculator, second cos of 10 divided by root 1000. Yeah, 1 over root 10. We get 71.56, which would be rounded to 72 degrees if we want to round to the nearest degree. Okay, so the last one is actually easier than the first two because they ask for the cosine of the angle. So we don't actually have to calculate the angle, we can just leave it as cos theta. So if we again plug in, we have cos theta equals, and I'm going to name my vectors A and B. It's going to be A dot B, or the dot product of A and B, over A times B. So A dot B, or the scalar product, is going to be 3 times negative 2 plus 4 times 1. And that is negative 6 plus 4, which is negative 2. Then the length of A is the square root of 3 squared plus 4 squared. That's where you use Pythagoras. Oh, okay. Okay, so then 9 plus 16 is 25, so that's going to be 5. Then B is the square root of negative 2 squared plus 1 squared, which is the square root of 5. To the formula, so we get cos theta equals, the dot product was negative 2 over A times B, which is 5 root 5. This time we need to rationalize because we haven't simplified here. So if I multiply by root 5 over root 5, I'm going to get negative 2 root 5 over, what's the bottom? 25.